Hey everybody, my name's AJ Perez. They call me Alfonso, that's my legal name, but I go by AJ. And I'm the CEO of NVVOTS. We're a Boston-based hardware, robotics, software, everything that comes together company that's all focused on building easy to use and easy to share 3D printers. By a show of hands, who knows what 3D printing is? Okay, who's used one? All right, great. So the people who have used it probably know about this problem, but for those of you who don't, I'm going to explain it. The fundamental problem that we faced when we invented automated 3D printing, and I'll explain what I mean by that when I take you through the problem, was that if I had my own 3D printer and I wanted to let everyone in this room use that 3D printer, state of the art is that you email me the digital file that you want printed. Then I have to open up my laptop with your file, download it from my email, process that file, create the equivalent of the machine code that makes your printer work. Essentially, you have the drivers locally on your device. Then you have to take that file on a flash drive, walk over to your printer, plug it in, hit go, and then when it's done, take a paint scraper and scrape it off. And then if I want to print the next job and the next job, I have to be heavily involved in that entire process. And it's not an easy thing to do. When me and my co-founders started getting into this, and I'll get into it in a minute, we actually didn't set out to build a 3D printing business. And I'm going to walk you through today how we kind of sort of serendipitously fell into starting a 3D printing company and walking you through our early entrepreneurial journey. And I called this talk An Entrepreneur's Hardware as a Service because I'm sure a lot of you have heard of software as a service. It's the business model of Silicon Valley for the last 2 decades. And we've kind of done something a little different where now instead of software, there's a hard physical component to what we do. I'm going to start out by listing a bunch of useful terms in hardware that you probably won't have heard of. Talk through with you about how it all began, where we discovered the big problem in 3D printing, the turning of NVBots into a revenue-generating business on our seed capital alone, and then what does it mean to do operations as a hardware company as opposed to, say, your conventional software or service business. So there's 5 terms that I want to talk about. BATNA, which is your best alternative to negotiated agreement. This is when you go to the table with an investor or a supplier or a contractor. This is your walk-away term. What would you do if that person decides not to do business with you? A contract manufacturer is someone that's a business partner that fabricates or assembles part of your product under your name. Incoterms are a set of terms, international standards that allow you to discuss with a supplier who's paying what on shipment. Are you dealing with the taxes and tariffs, or are they dealing with it? Are they insuring it, or are you insuring it? This is really important, especially if you're going to design something in your country and have it manufactured somewhere else. Tariffs become a big issue. Thankfully, in the EU, a lot of those problems don't exist, but if you're planning on importing from China, there's a whole heck of a lot of work that has to go into this. And I call this one out in particular because I've been burned by it. Thankfully, we got burned at a small enough scale where we thought, oh wow, this price in China is really, really good. And then it shows up and then we get a bill from UPS because they didn't tell us that we were stuck paying the shipping bill. And that was buried in the Incoterm contract that we had with them. And then the payment terms. This is a really, really important one because unlike a software company where your cash flow is almost 100% headcount, you have hard capital assets and raw materials that you have to deal with. And if you have to pay your suppliers before you get the part and your customers don't pay you till 90 days after you deliver it, you need to have enough cash in between to cover all of your operations, not just headcount. All right, how it all began. I talked about we a little bit. These are my co-founders and myself. We were all from MIT. We're actually all fraternity brothers. You guys know the company Dropbox? We started our company out of the same bedroom that Dropbox was founded in our fraternity. And it was kind of a weird thing that happened, which was I was working with Chris on a really exciting problem to automate the way clothes were made. I was working with Forrest to make programmable lights that would respond to ambient conditions like sound and acceleration. And I was working with Matteo to make kind of this a Segway of skateboards is the best way to describe it. You lean forward, it goes faster. You lean back, it regenerates energy, and you can control the dynamic stability of it. And we ran into this common problem at about the same time in the summer of 2012, which was We got far enough in the detailed design phase, which was we were sitting at whiteboards, coming up with ideas, throwing around different functional requirements, what the product needed, what the product didn't need. And we got to the point where we said, hey, we've got a design for our prototype. We have a CAD model now. And we're in this weird position, which is we're all still students at MIT. And they have this really interesting provision that if you do something using their resources or their labs, they own the intellectual property outright. And that was something that terrified us because these were all ideas that we were interested in pursuing as businesses. So we said, hey, we've got an idea. What if we built a 3D printer first so that we could do all the prototyping ourselves? And being the broke college kids we were, we couldn't afford to go buy one, so we had to build one from scratch instead. And in building it, that's where we actually learned about something. But we didn't start by building the 3D printer. We actually had a more fundamental problem, which was we needed a place to build the 3D printer. So we first built our workshop, and this gave us the flexibility and a clean environment to work together. This is in the basement of a fraternity house. Right above here is where all the beer drinking and partying happens. So it's kind of this weird dichotomy if you go from this typical, what you imagine as Animal House, something like that, and then you go downstairs and the next generation of manufacturing technology was being born, but we didn't know that yet. And this is a picture of the first prototype that we built. We didn't design the printer from scratch. We actually worked with some open source standards that were around called the RepRap project. And I was really, really excited when we finally got our first printed part. This thing is absolutely terrible to look at. It was not supposed to look like this whatsoever. It was supposed to be this perfectly beautiful rectangle, but instead it kind of looks like a corn on the cob. But that's when we realized there was a really big problem, because there were 4 of us, and we all wanted to use the 3D printer for our own uses. We weren't all focused on one common problem at the time. There were 3 different ideas that we were working on. And that meant 3 different ideas had to share this one piece of capital equipment. And we realized that that capital equipment required a person to be physically present at it. And now I want to describe and physically explain that workflow that I talked about before when using a 3D printer. This is truly where the magic in 3D printing happens. It's on the design phase. If I had to describe 3D printing at a high level, the process from a user's perspective, there's CAD, there's CAM, and there's the actual printing process. CAD is computer-aided design. This is where you're using software tools and graphics engines like SolidWorks to actually create a 3D model. CAM is where you're taking that 3D model, chopping it into layers, specifying how fast the head's going to move, what acceleration, what temperature the plastic's going to come out at, and so on and so forth. And then the printing process is every step from you took your code to actually getting the part off of the printer and doing the next job. So that's really where it's a physical operator process, somebody who's a trained machinist in some sense. So this is the CAD process. This is really where all the creativity happens. There's nothing creative in CAM. There's nothing creative in operating the 3D printer. This is where 3D printing is going to change the world, not in CAM and in the actual manufacturing process itself. It's what you can do with the tool and how flexible it is. But what we realized is once you go from that really creative CAD process, you now also have to be an expert at CAM. And what I'm talking about is you have to go in and physically optimize all these different variables. And you have to open up this slicer program. And once you got slicer, then you have even more variables to deal with. And these aren't simple. It's not like, hey, I want it to go fast versus slow versus medium speed. You can give it infinite decimal places, and this software program will crunch the numbers no matter what, because it's really smart at math, but it's not smart at understanding the physical process that it's doing. And that was a real difficulty for people, because it wasn't just this page. There was more variables and even more variables that you had to optimize. All said and done, there's over 150 variables. And they are non-linearly dependent on one another. So if anybody knows anything about math or optimization, if I told you we had a non-linear, multi-dimensional optimization problem to solve, who in the audience wants to take a crack at that problem? Every time you want to 3D print something. Nobody wants to do that every time they 3D print something. And this is what we realized was a huge pain point. But we also realized that that's from the use case perspective, that from a sharing perspective and utilizing your capital equipment properly, every 3D printer on the market lacked this fundamental piece of technology which removes the part from the 3D printer. I'm going to ask a very basic question here. Imagine you had a paper printer and you wanted to print 20 pages and you had to be there to remove page 1 for it to do page 2. How often would you use that paper printer? Not very often. It's not user-friendly. And we did that to 3D printing. And when we originally invented it, it didn't seem like we had invented something new. It seemed super obvious to us because it was solving this very fundamental problem of I did not want to wake up at 3 in the morning to remove a part from a 3D printer that was worth maybe $3 in plastic to me, but my time I felt was worth a lot more, especially my sleep at 3 in the morning. And let me show you an example of what happens when you don't optimize your variables properly. You get this. You get a spaghetti bomb. And this is what happens when you use some of these cheaper, off-the-shelf solutions that leverage that open source software that hasn't been intelligently optimized. You get problems like this, where this is a complex machine. You're trying to get it to create a really fancy geometry. And when you leave your machine unattended and you're not observing it, you think the part quality is perfect up to the top of the pineapple, and then it doesn't print, and then the pineapple is really sad because its head exploded. And this happens all the time. This is one of the biggest frustrations of failed print jobs for people. And then there's an even more fundamental problem, which is if you want to print something that's precise, and you want to see 3D printing go from this rapid prototyping technology that's just used for early ideation and actually make the leap to manufacturing and cross the chasm, so to speak, you actually have to think about the fundamental physics of the process, which is if I want something to come out square, I can't have a bed that's tilted to the side and my head be up here. Everything needs to be perfectly perpendicular and perfectly parallel where it's supposed to be. And one of the big issues, you get these cheap machines, over time, they use this screw design. And with this screw design, what happens is that's how they level the print plate. And over time, as the head moves around and you have these really poor open source designs, that vibration causes those screws to lose levelness. And we're talking about microns here, microns of precision. If you took one of the hairs off your head, my machine is 10 times more accurate than the size of your hair. That's really, really difficult to maintain, especially over a long lifetime. And now if you want to maintain that tolerance for a machine that's running 24/7, you have to take the level of design thinking that goes into that machine and take it to a completely different level. You're now talking about designing manufacturing equipment, not toys for kids. Though, at the end of the day, it can still be used for kids. And that's what's exciting about the technology. And now I'm going to talk to you about turning NVBots into a revenue-generating business. And I want to give you context here. I'm going to take you through from the birth of the technology up until about 2014 when we left MIT and got our first bit of funding. And if you want, you can come to my talk later, and I'm going to tell you a lot more about the state of the business today and the state of the technology today. This doesn't take us to where today is. This takes us to where we were about 1.5 years ago. This was our original business model. This was before I went and did a bunch of entrepreneurship programs and accelerator programs. What we thought up was this really clever idea that if I think that this is 10 to 15 years out, and this is going to be what makes the most money in the industry, but this doesn't work today, and there's some fundamental reasons why, and I'll explain them. So the concept was a user could log on our website, they could select a design file from our library, kind of like iTunes, if you imagine, or Amazon. But instead of having a physical inventory held at Amazon's warehouse and they ship it to you, this is done a little bit different, where now all we hold is a digital inventory of the parts. It's a digital catalog. And then that model is processed on our cloud interface, sent to somebody's printer, automatically printed out, they box it up and ship it. That doesn't work for two fundamental reasons. One, there's not enough good content. It's a lot cheaper today to go out and buy a cell phone case and get it conventionally molded because there's economies of scale in China, and 3D printing isn't there yet from the economic perspective. And the other fundamental issue is this process right here. You can't send a print job from the cloud to a printer today without our printer. There's very few that can even do that. If you want to pay $500,000, sure, you can do it. But there's nothing under a sub $10,000 price point that automates this entire process. Everything else requires you to be in the middle with a computer. There's a couple instances when you can use your laptop and send a job when you're right next to the computer, but that's about the extent of the automation that has been seen in the industry. And that prevents us from actually making this a seamless process. So what we did, this is our original prototype. These are all my co-founders. And what we did is we went to the MIT Tech Fair and demoed our 3D printer. This was back in February 4th of 2014. I remember that date because 3 days before we filed our patents, or maybe it was 4 days before. And that was really, really critical If you guys have invented something, do not show it to the world until you filed a patent. If you do, anybody can use it and your patent doesn't work. You'll waste your money and all your time trying to get that patent, and it'll be void. Anybody will take you to court, they'll say, hey, I saw that presentation before you actually invented it. So one of the keys that we did is we patented it before we did this, but bear in mind, we were not trying to start a 3D printing company. This was a couple of nerds that invented something cool and wanted to show it off to the world. And what we learned at that tech fair was from our customers. We had people that were like us that had built a 3D printer either in their lab, in their dorm room, whatever it was, and they came up to us and said, I'm paraphrasing here, holy cow, that's amazing. I have that same problem. I hate waking up in the middle of the night to start the next print job, but I need it tomorrow, so I have to do it. How can I get this for mine? And then on the other side, I had people that were lay people, kind of like my mom, that would say, hey, you know, what's so special about this? Because you look at it, this is a rat's nest of wires here. It's your quintessential prototype. It made a lot of noise, would bang around and stuff like that. And then we would explain very proudly, this is the world's first fully automated cloud-connected 3D printer. And they would kind of give us a perplexed look and say, what does that even mean? And then we would explain, you know, this is the first paper handler for the 3D printer. This is the first 3D printer that has cloud drivers. You don't need drivers on your computer, and you don't have to optimize that toolpath anymore. And then they said, oh, I thought it was already like that. So we got these two nuggets of information, which is early adopters and technology enthusiasts said to us, that's exactly how they expected the technology to behave. And then we had people that don't use the technology today, had heard of it, and said that's how they expected it to behave. And that's when the light bulb went off in our heads that there was something that we should pursue here. And that's exactly what we did. We started to give some demos of it too. This is Forrest, that's Chris, that's Mateo, I'm taking the picture. And these are a bunch of little kids. These kids can't be more than 8 years old. I think most of them were in the 5 to 8-year-old range. And that was really exciting. These kids were fascinated by what we had done. Good luck getting them to pay attention in class to a teacher lecturing on in front of a board, but you put a 3D printer in front of them and they are glued to it. And that was something that was really, really interesting to us. But we didn't pay attention to that for a while. Bear in mind, this was still when we were pursuing that marketplace business model where anybody could sign up their 3D printer and rent out time on their 3D printer. But then we did the Global Founders Skills Accelerator at MIT. And this was a really, really interesting and unique opportunity for us. We were all still students at MIT. We got to spend a summer, instead of interning at other companies like we had done before, and in a lot of cases taking about a fifth of the pay that we would have gotten going somewhere else, to pursue our own business. That was a really big leap for us, was to persuade the guys that I was working with that this was the right thing for us to do, to go and learn from some of the best entrepreneurial minds in the world. You mentioned Kiva Systems. One of our simulated board of directors members was the CTO of Kiva Systems, the guy who invented warehouse automation. And we had some of the best mentors in the world. And what was so exciting is that if we hit all of our milestones, we got money for free. And there's a lot of programs at educational institutions that are starting to copy this model. In a lot of cases, accelerator programs will take a chunk of your company, 5, 10%. I encourage you to apply to the ones that don't take it, because they are going to be your best friend. They're going to be aligned with you as an entrepreneur. They're going to have a vested interest in your success. And what we learned is that we needed to talk to people. We needed to talk to customers. And when you think back to that picture of all those kids around the table looking at the printer, that kind of sparked a light in our head that was, wow, we were students in school that wanted to do rapid prototyping and invent a new technology, but we couldn't get access to a 3D printer, so we had to build our own. And then when we saw all the kids getting fascinated by it, we realized we weren't alone in this education space of being interested in this technology. And we also found out that older people were kind of the perspective, hey, you know, this is interesting, but you know, it's not there yet. It's not what I saw in Star Trek, so I don't think it's cool. But you get little kids and their faces are glued to it. That's when we kind of realized this is going to be a generational thing. Education in this space matters fundamentally. Because what I was talking about before, the design space, where you can do everything that's creative. My talk later is going to be about how design thinking for 3D printing differs from design thinking from conventional manufacturing. And there is a very fundamental difference. If I wanted to machine a block of aluminum and put a hole in it, let's say just drill a hole in a block of aluminum, As a manufacturer today, if I wanted to use a CNC mill, which would be probably the tool of choice, or a drill press, your optimization problem is to minimize the size of that hole. And the reason is, if the hole is smaller, you waste less material, you spend less time cutting it, and you depreciate your machine less. 3D printing, on the other hand, because you can literally create objects from the inside out, from the bottom up, your optimization problem is to make that hole bigger so that you put down less material and you waste less material. And you don't want to make it completely solid. You want to make it semi-hollow on the inside. You can do things with a 3D printer that are physically impossible with other technologies. You have to think about it from the inside out. The field in academia that 3D printing is created is what's called additive manufacturing. Drilling is a subtractive process. You start with a block, you remove it away. The additive process, you're literally building it from the ground up. And what I found is most people were ignorant to that design thinking change. And that was a fundamental reason why we had to start with the education space. Is I could take this product and I could go and sell it to big companies, Staples, Ford, Boeing. With MIT's network, I could get in front of the VP of engineering at any of those companies. But the fundamental problem was that their engineers were not equipped with the toolkit that they needed to think rationally about 3D printing. I think you had the quote, Steve, that it's foolish to try and do the same thing over and over again and expect a different result. What's even more foolish is to expect to take a conventionally designed thing, put it on a new piece of technology, and it to be cheaper, better, faster. That's foolish. You have to design for that new technology that you're using. And that's fundamentally why it starts with education. From a business perspective, it was great for us. MIT has one of the strongest brands in education. We got to go out to conferences and start to talk about this with MIT's brand behind us. Faculty got really excited about everything that we were doing because what we were fundamentally enabling was kids to put their face in front of the 3D printer, but not only that, teachers to print out models, say DNA, or a gearbox that you would normally just watch a video on a screen like this and put it in your hand. It enabled hands-on learning. There's a big fallacy, which is that there's two types of learners in the world, auditory and visual. It's a lie. There's three types of learners, auditory, visual, and hands-on learners. And school beats the hands-on learning out of us. But that's what made MIT such a great place, is you can couple book learning, the visual and the audio, with hands-on learning. And that's what we're able to promote as a business, is hands-on learning in that academic environment, because the 3D printer can create any tool, any lesson plan for any teacher. I can print history. I can literally print Greek artifacts in a classroom in the middle of Arkansas. Things that they would have to come over to this side of the world to see, and now we're enabling them to make history in their classroom. And you couldn't do that before. Now this is where it's as a service. I told you about the hardware component, that we built something that was really cool. This is the as a service part. These are not our prices today. These were our introductory alpha prices to help us sign up customers. The model worked something like this. We build a 3D printer. We rent you a 3D printer. A lot of customers were afraid. They had this technology obsolescence risk, which was you buy a computer today, in 2 years you have to buy a new computer. And they've seen the same thing happening with 3D printing. More and more people are entering this market. More and more people from China are making cheap printers. And they don't know how to cut through the noise because they're not educated enough on the topic. So what we did is we said, we're putting our money where our mouth is, and we're giving you a free upgrade in the future if we come out with better hardware. And that's how this rental model all came together. And then what we were able to do was bundle everything. So what we were providing was the software where you could go online and send print jobs to the printer and manage who was printing when. Then we also provided the actual material. So there's this element of the razor blade in our business model as well. And then when you think about it, we have these users. We're giving away the users. So this is kind of the freemium aspect, and this is the software as a service aspect to it. But then we also have a service component to the business where I'm warrantying your machine. I'm guaranteeing you that it's going to work and that you're going to have a perfect user experience. The key that I'm pointing out on this slide isn't the money, isn't what we've bundled together, but the impact that this has strategically as a business, as an entrepreneur, what you have to think about. I came from a consulting background moving into this. That was where all my internships were. It was in strategy consulting. And one of the interesting things that I like to take away from that is thinking about key performance indicators for your business. If you're a CEO, you don't have time to manage and track 1,000 different metrics about how your business is performing. So I picked one for our business, which is what is our churn rate. That's what is the percentage of customers that in year one that leave you in year two. Because for a recurring revenue business model like this, that's all that matters, is that you have customers that stay with you for the lifetime. If I can get a customer to go from year 1 to 5 years, my margin grows through the roof. In the first year, we hardly made any margin. If not, we were losing money. This is kind of like when you lease a car. The first 2 years of leasing a car, you lose money. The third year of leasing a car, you start to make money as an auto dealership. The fourth year and the fifth year is all gravy. But if you're not able to get there, if you don't have high customer satisfaction and good customer service, you could never get there. So that's how we realized that this all came together. And our business focused on this churn, this concept of making sure that we keep our customers. A lot of other 3D printing companies are going for this kind of philosophy of, let's make 1 million of these things, throw it into the marketplace, they'll all break, and then those 1 million people may or may not come back to us next year to buy another one, but who cares because I'm making money from it. But we're talking about doing good and making money at the same time. Something that's really important to me is having a good reputation. And we wanted to make sure that any customer that worked with us was satisfied. So this is the exact opposite of that pump and dump philosophy, which is to make a bunch and sell it. We make less products than we should, and to make sure that we have a good user experience. And now I want to talk a little bit about our Alpha program and how we got off the ground and how we got traction. One of the big issues when you're selling to education is academics want to know that it works. And getting those first few people to buy into it and give you good testimonials is really difficult to do. But in this space was absolutely critical. And since we had these really, really good experiences, we got feedback that us using it ourselves was never going to give us, because we were experts at it. We literally built it from the ground up. So of course we were going to understand how it worked. But when you put this in front of a 10-year-old and a teacher that has never used technology like this before and they can do it, or when you see them struggle, you learn how to improve it so that they can do it. And now I'm comfortable enough to put this in any classroom with any teacher, give them a 4-hour training session, give them access to some of our videos on YouTube, and now they can use it and teach the entire next generation of students how to leverage this technology. And we couldn't have done that if it wasn't for these 3 partners that we started out with. And I'm immensely thankful for what they did. And then we partnered with a couple of other organizations in the education space. First Robotics opened up a network of over 20,000 schools that we could sell to. Autodesk gave us the CAD software. So we focused on the CAM and the printing, and then we were agnostic. We can use any CAD program. But what's really cool about Autodesk is they give it to students and teachers for free. And that's a big deal. So now we have an entire package. We can give CAD, CAM, and printing to any school. No other 3D printing company could offer that. And then what's also really cool is we partnered with Citizen Schools. I'm going to talk a little bit more about them. These were inner city school kids in Boston and around the United States, but we focused in Boston, that when I went and taught this class of 10-year-olds, that they said there's no way you're going to be able to get them to learn 3D modeling, let alone be able to use a 3D printer and get them to sit in the chair for an hour. But we proved all the naysayers wrong. And we actually see here, there's a 10-year-old child teaching a 50-year-old government official about 3D printing. Because in our first lesson, this 10-year-old child was able to come up with the design and 3D print it within an hour. We've created a piece of technology that's that simple for them to use. There's no chance they would have been able to do that with any other 3D printer on the market that wasn't connected and automated. And more importantly, if it wasn't connected and automated, we would have had to deal with the burden as the teacher to make sure that they had that tool to use and learn from. So this makes it easy for everybody, the teacher and the students. But now I want to kind of extrapolate that a layer back and think about that from a user and an admin perspective. This isn't just useful in an educational environment, but education is where it started. And we got recognized for it. We won the MIT Lemelson Student Prize. I put this in here because it's something that really, really excited me. And why this was so cool for us is the faculty member that runs the Lemelson program is the co-inventor of one of the seminal 3D printing technologies. Back in the 90s, he invented 3D printing. So this was a stamp of approval from him in some sense that we did something that was big. This was really exciting to us. And this gave us a little more startup capital. This kept us going. And I want to talk about early operations. I'm going to have to fly through this because I have 58 seconds. I'm sorry. These different, I want to just show you. We took it from building our workshop and in a matter of less than 2 years had a full production 3D printer ready to go into the marketplace. We've iterated now to date through over 15 different versions of our hardware, let alone all the different software iterations that we have. We do software pushes now every 2 weeks. So we had agile software development, But as a hardware company, we pushed it to agile hardware development, which is kind of a weird concept, but you can do it. All right, I'm going to talk about this in my talk later, so I can go over it. But you have to think about it. There's a lot of misconceptions about insourcing and outsourcing and offshoring and onshoring. You can insource and offshore at the same time. You can outsource and onshore. A lot of people think outsourcing means going to China. Outsourcing means going outside of your company. And that's a big thing to understand about core competencies, is that if you are going to go outside of your company for something, that you are losing that ability to do that in the future as an organization. And do I have time to finish these up? Okay, all right, so I am going to take my time on them. So I want to talk about some of the things that you need to consider when you're picking suppliers. These are the questions you need to ask yourself if you're doing anything related to hardware, which is, where are your suppliers located? What's your diversification strategy? Any hedge fund manager would never allow you to put all your stock in Apple. They would tell you need to bet on all the big blue chips. Same thing for manufacturing suppliers. Don't put all your eggs in one basket. If a hurricane comes through, like we saw back in 2011, or a tsunami can come and wipe out the entire chip manufacturing for most of the world, and if you don't have a diversified supply base, your business is gone. What's the expected lead time? What's the probability that the expected lead time is correct? Who pays the shipping, the taxes, the tariffs? That's the kind of stuff that I was asking you before about Incoterms and telling you about. You need to know the answers to all these questions. And then who's doing your quality control and incoming inspection? I'm giving you a little case study here on NVBots. Something I'm very proud of is, with the exception of components that are only manufactured in China and nowhere else in the world, when we have the option to, we pick America first. And that's really exciting to me because we have one of the few 3D printers in the US that's wholly manufactured and assembled and designed and produced in the United States. What's our diversification strategy? What this is we're talking about leverage here. I have one supplier that does 70% of my business of, let's say, widget 1, and then another guy that does 30%. The guy who has 30% wants to get to 70%, and the guy who does 70% does not want to lose his 70% and only do 30%. So this allows you to take two different suppliers, negotiate them, and pit them against each other in a pricing war to get the prices down, but also ensure that if supplier 1 is hit by a blizzard, supplier 2 knows how to do your work and has the capacity to do 100%. That's critical. If you have a really hard to make thing and you only have one person that makes it, and the guy that knows how to make it gets hit by a bus, what happens to your business? You need to think about risk mitigation and things like that in the context of your supply chain as well. And I asked that question, what's your lead time? It was kind of a loaded question because it varies by the part that you're making. I have some that I can get tomorrow, and there's some that take me months to get because they're really high precision, high tolerance components. And I gave you the warning before about who pays the shipping and the tariffs and the taxes and stuff like that. Bite the bullet. Most of the time you're going to have to do it and just accept that and factor that into the prices you're going to pay. And something I really encourage you all to think about is looking at places to start your business that have no taxes. When we actually scale up our production into full-scale production outside of the prototype production, we're definitely going to move to a place that doesn't have sales tax and income tax. It makes it a lot cheaper to hire people and makes it a lot cheaper to sell product. If I could tell you that I can sell you a product by 8% by standing on this side of the New Hampshire border as opposed to Massachusetts, it's a really simple no-brain decision. Go to the place where there's no tax right over here. And then who does your quality control and incoming inspection? This is a big question you need to ask from a core competency perspective. There's a lot of people that go out and design hardware and then they say, here's my design, Mr. Manufacturer, make it. And then the manufacturer sits on the other side of this black curtain and makes it. And then when that manufacturer loses all their other business and you're their only customer, they can no longer exist, and now they're gone, and you're sitting there with a product, customer demand, and no way to manufacture it and no means to manufacture it. You need to ensure that if you're not going to diversify your supply chain, that you understand how to manufacture your product. That is absolutely critical to your business and ensuring the longevity of your business. I'm going to skip that one. Actually, I'll go back to it. Why not? I've gone over time. Managing your suppliers. It's a full-time job. Nobody tells you this, but it's 100% full-time job. And I know a lot of people in the startup economy, especially on the West Coast, like to wake up at 10 o'clock, get to the office after they go surfing by 11:30. If you're in the hardware space, you cannot do that. Your suppliers work 9 to 5. Your supply chain manager needs to work 9 to 5. It's that simple. You have to be there on the phone calling them when they're outward-facing vendor is in the office. You can't get a hold of them. And if you limit your business to half a day, you're going to get half the work done. So you just have to accept that. And that's what I mean by payment terms. Before I was talking about cash flow and things like that, this is absolutely critical as a manufacturing organization. Your supplier, in their ideal world, would get paid 90 days before you order the product. In your world, you pay them 90 days after they deliver the product. And then everything else is a negotiation in between. And the further and further you can get towards, I'll pay you 90 days after the product, the better off your business is. And there's two big reasons why. One, it helps your cash flow. But two, if you have suppliers that think you're credible enough to give you 90-day payment terms, that looks good for banks, because now you're credible enough to other organizations. It gives you credit. This is a way as an organization to build credit up with your suppliers and leverage that into debt financing so that you don't have to be 100% venture-backed or sell all the equity in your company. Now you can start to do really creative things to manage your cash flow on the debt side and leverage equity for growth rather than for near-term cash flow issues. This is really, really important to understand, and I encourage you all to go and study the financials behind it. It's really hard in the early days to make demands with your supply chain. For instance, we order a lot of stuff through McMaster Carr for our prototyping. We have absolutely no leverage over a supplier that's that big. So if you're a small company designing a small product for a small market, start with a small supplier. You will have leverage over a small supplier. You will be able to get those payment terms from a small supplier. Because as soon as you hook them on and you're 20, 25% of their business and they have employees that are relying on you, you can get on the phone with the CEO of that company and say, hey, if you don't bring down our price or give me better payment terms, I'm going with the guy that's down the street from you, and you're going to lose a quarter of my business, which means you're going to have to lay off a quarter of your workforce. They're going to give you the payment terms that you want because you have them under your thumb in some sense. Always think about leverage when you're negotiating your contracts with your suppliers. And then the last piece, this is where you have to know your BATNA, your best alternative to negotiated agreement. Almost every supplier you're going to work with the first time is going to demand that you pay them 100% upfront. But if you have working relationships with other suppliers and good lines of credit, you can go to a new supplier and say, hey, I've got this letter from another supplier that I pay them on the time. I've never missed a payment ever, and they give me net 60 terms. I'll start with net 30 for you. If I don't pay you on time, we'll go back to 100% upfront. But if I get to net 30, then I want net 60 as well. And you can use this as a negotiation chip when you're actually talking with your suppliers. Leverage your other suppliers against each other. That's where this diversification strategy really benefits you, not just from a risk mitigation perspective, but for keeping your costs down in the long run. And with that, I want to thank you all for listening to my talk about hardware as a service. And please come to my talk later about design thinking. Thank you.